In the beginning, God said, "Let there be light." And there was just what exactly? What is light? How does it differ from darkness? Some early Greek scientists thought the eye itself was the source of light. They believed that light was a kind of streamer. These light streamers were emitted from the eye. Without the eye, there could be no light. Others believe light came not from the eye, but from different sources. But whatever the source, it seemed reasonable to believe that light traveled from one place to another. Attempts were made to measure the time it took for light to travel or propagate. Unfortunately, scientists could not observe the propagation of light. In some mysterious way, light appeared everywhere, instantaneously. This was beyond human understanding until the invention of the telescope. In the late 17th century, Olaf Romer studied light from Jupiter at several points on the Earth's orbit. His observations could only be explained by assuming light traveled across the Earth's orbit in about 16 minutes. That's a distance of more than 300 million kilometers. At last, here was evidence of the enormous speed of light. Scientists had long searched the familiar world around them for models to help explain propagation of light. Not long after Romer's observations, the respected scientist Sir Isaac Newton lent his weight to a particle model of light. His particle model was the first to explain several important behaviors of light. Newton made carefully reasoned assumptions about things he could not observe. He knew that when a stream of actual particles intersects with another, there are always collisions. These collisions cause particles to spread out from the intersection. But when two beams of light intersect, there's no evidence that light particles collide and spread. So Newton assumed that the light particles must be incredibly small, too small to ever collide with each other. Newton also made an assumption about particle motion. He knew from observations that moving particles are pulled by gravity to follow a curved path. The faster the particle, the straighter the motion. So Newton assumed a particle moving as fast as light would show straight line motion or rectilinear propagation. This assumption about particles matches experiments with light and shadow. These experiments show that light tends to travel in straight lines. Particle behavior can explain several well-known properties of light. traveling particles tend to bounce off a barrier. The angle at which a particle strikes the barrier matches the angle at which it leaves the barrier. This geometry of reflection can be demonstrated with many particles. And at many angles. This particle behavior is a good model for light, because a beam of light reflects from a mirror in the same way. Another behavior of light is refraction. Newton knew that transparent substances, like water and glass, distort light. It seems as if light bends as it enters a new medium. But why? Newton proposed that all particles of matter exert an attraction on every moving particle of light. This attraction is balanced in all directions, so light normally travels in a straight line, except near the edge of another substance, such as water. A light particle approaching the surface of water encounters a stronger force of attraction. This causes the light particle to bend towards the surface and speed up. Once inside the new medium, the greater force of attraction pulls evenly from all sides, so the light particle continues in a straight path. However, Newton had no way of showing that light actually travels faster in water. It was one more assumption necessary to his particle model. Yet another behavior of light is dispersion. Newton had himself discovered this property of light. He shone light through a slit to produce a narrow beam. With a prism, he interrupted the beam. The prism split white light into bands of color. To explain this behavior, Newton suggested that a beam of light is a mixture of particles of different sizes. The surface of the glass attracts them, and they bend according to their size. So the prism separates light into streams of same-sized particles. These streams appear as different colors to the eye. Just how solid was Newton's particle model? Newton himself was cautious about it, but his famous name was enough to sell the scientific community. In spite of attacks, especially from another important model, Newton's model survived and was accepted for nearly 2 centuries.